cloud. Okay, worked. All right, let's get started. First of all, let me congratulate Kyle. Kyle is the Spotlight student of this week. Is Kyle here? Is Kyle here? Oh, Kyle just came in. Okay. All right, Kyle is the Spotlight student of the week because he not only did all 4 problems correctly, he also did part of a problem 5 correctly. So he's the Spotlight student. In addition, we have 2 runner-ups. So that's Eric Shao and Leo Hong, okay? So in total, 3 of them had all problems answered correctly. I mean, all required problems. The first 4 problems answered correctly. Okay, I think Kyle is here. Kyle, you can pick a problem you want to discuss. Which problem would you like to talk about? Somehow. Okay, Kyle, you have 2 accounts. You want to pick a problem?
Yeah. What happened just then? It was kind of weird. So I just entered the meeting and then I couldn't press anything, so I had to reload the app and yeah.
Okay,
so,
that's fine. Pick a problem you want to talk about.
I don't know. But first, I actually want to talk about the general formula.
A general formula. How about you start with the first problem?
Okay.
Okay. And then Leo and Eric. Well, Leo had part of problem 5 answered correctly. So Leo, you can pick one. Which problem would you like to talk about?
I'll talk about number 2.
Number 2. Okay. Eric, which one would you like to talk about?
I'll talk about number 3.
Number 3. Okay. I think. Oh, actually, no, sorry. It was not Eric. I think the other one who answered correctly was Shiyun. Okay, Shiyun answered all of them correctly. Well, that's Shiyun, you can pick a problem too. Okay, would you like to talk about problem 4?
I wanted to talk about problem 3.
3, okay. Well, you have 3. Eric, how about you do 4?
Okay.
All right, so we have Kyle number 1, Leo number 2, Shiyun number 3, and Eric number 4. Okay. But I want to start with the second problem. I think the second problem was actually an easier one. Okay. Let me pull the problems. Okay, I want to start with the second one. All right, so basically it's saying I'm taking 3 mooncakes. Well, it's mid-autumn day. It's a Chinese tradition to eat mooncakes. Have a family sit together, eat mooncakes, and look at the moon. Right. So I took out 3 mooncakes and I cut it into 4 equal pieces. And the 3 mooncakes, the same flavor. So we can consider all these 12 pieces. They are the same. Okay. So I want to start with the second problem. So it said if Leo has to give at least 1 piece to each family member. Okay, Leo has to give at least 1 piece to each family member. How many different ways can Leo allocate the mooncake pieces? Okay, so in total there are 12 mooncakes, 12 pieces. And Leo need to give 5 family members. 5 family members. At least 1 per person. 1 each. Okay, go ahead.
So basically, you can first give out 1 to each person.
Okay, so let's say there are 5 people. You want to name them?
Okay, H, W, L, A, E.
Okay, so H is Dr. Hong, W is Dr. Wang, L is Leo, A is Angela, E is Ela. Okay, so you give them one of them each.
Yeah, you can just pre-give them.
Okay.
So it's basically really just asking for 7.
Okay, now you have 7. 7 left. Okay.
So then I first did it as if H, W, and L all got 0, not including the ones.
0, 0, 0. Yep. So now we're allocating the remaining 7. Okay. 0, 0, 0.
So
3 zeros.
yeah. So then with A and E, there would be a total of 8 ways.
8 ways. So what are the 8 ways?
Well, A gets 0 through 7, and then E just gets a corresponding one.
7 to 0. Okay.
So that's a total of 8 ways.
8 ways. Okay. So these are 8 ways.
So then if you instead make it H and W are 0, and then you start changing the L
Okay.
to L, A, and E,
Okay.
then it would be 8 plus 7 plus 6 all the way to 1.
Because you can make L to 1, 2, all the way to what?
All the way to 7.
7. Okay.
You can also make L 0.
Well, you already had L equal to 0 here, right?
Oh, yeah, okay.
Okay.
So then it's just 8 plus 7 plus 6.
So then this will be how many ways here?
7.
7 ways. So this, when L is 1, A could go from 0 to 6, right?
Yeah.
So E can go from 6 to 0.
Yeah.
So there are 7 ways. So then 7, 6, all the way to
1.
1. Okay.
So 1 all the way to 8 is 36.
So these in total is 36. Okay.
So then you start changing W.
Okay.
If you start changing W, then it would be
So
8 plus,
give 0 to H.
yeah,
All right. And then W, you have 1 all the way to 7.
yeah.
Okay.
So then you already have the 8 on 1 all the way, 1 plus 2 all the way to 8.
Mm-hmm.
So then if it was 1, then it would be 1 plus 2 all the way to 7.
Okay. So if this is 1, here will be 1 plus 2 all the way
Which
to
is
7.
21.
Okay. It's 21.
And you do the same, and then it will be 1 to 6, and a 1 to 5,
Okay.
and
The
so
next
on.
one is 1 plus 2 all the way to 6 is what?
15.
15.
All the way to just 1.
1 all the way to 6 is, no, 1 all the way to 7 is not 21.
Well, I mean 28.
Huh?
28.
28. Okay. Here is
21.
21.
And then you keep on doing it
Mm-hmm.
all the way until it's 7, which there will be 1 way.
Okay. 1. Okay.
So then I found that if you have like 1 plus 2 all the way to x, that would be, well, n, that would be n times n plus 1 over 2.
Okay.
And then if you add it to 1 all the way, 1 plus 2 all the way to n minus 1,
Okay.
then it would be n minus 1 times n, or just n times n minus 1.
Okay.
If you add them up, you get 2n squared over 2 is n squared.
Okay.
So then I saw that you could pair 1 to 7 with 1 to 6,
1 to 7 and 1 to 6. Okay. So
1
this
to
is
5 with
49.
1 to 4,
Okay. 1 to 5 to 1 to 4.
and so on.
This will be what?
This will be 5 squared. 5 squared root is 25.
25.
And you
Okay.
keep on doing it
3
until,
and 2, that will be 9.
yeah,
And then
1, 0.
1 and 0, that will be 1.
Yeah.
Okay.
So then if you add them up, you get 75 plus 9 is 84.
84 plus 75 plus 84. Okay.
So then you just start changing H.
Okay. Started changing H. All right. So you make H go from 1 to 7.
Yeah.
Okay.
So first you have 84.
Okay.
Well, 84, which is like over there.
84 was 0. Okay.
Yeah.
Yeah.
And then you have 84 minus 28.
Okay. 84 minus 28. The first one, what H is 1. So 84 minus 28. Okay.
Which is like 56.
36.
And then for 2, you have 56 minus 21, which is 45.
Okay.
And then for 3, it's 45 minus 15, which is 30. And then for 4, you'll have 30. For 4, you have 30 minus 10, which is 20. For 5, you have 20 minus 6, which is 14. For 6, you have 14 minus 3, which is 11. And then for, wait, there's something wrong.
Something wrong?
Yeah.
What's wrong here?
Huh?
So if it's 7, it's supposed to have 1, right?
Yeah.
So what's wrong here? Which part was wrong? So when you have 1, okay, when you have 1 means the remaining ones, you will have 7, right? I mean 6, up to 6, right? So it's 1 all the way, add up all the way to 6, right?
Yeah.
So then W can go from 1 to 6. So it's 84 minus what? No, actually from 0 to 6, right?
Well, oh, you first need to subtract 36.
Subtract.
Well, I mean, you need to subtract, you need to, wait.
So this will be 120, right?
Oh, yeah.
Okay, so restart. Okay, 120
120 minus 28.
minus what?
Wait, minus 36
36, okay,
is 84.
okay,
84 minus 28 is 56.
okay. And then we keep going on, 45 and 30 and 20, and then 14.
And then 11. And then,
And what? Something wrong, huh?
yeah.
All right, you want to think about it?
Yeah.
Okay, go check what you did before. Okay, anyone else want to try this?
Kyle?
I have another solution.
Okay, David, Kyle, I'll go back to yours. Okay, because you have a more difficult problem. Okay. All right, go ahead, David. You want to
Oh wait,
continue, Leo? So try
I have
something
another.
different.
I mean, before I explain. Can you tell me if I got it correct or not?
What's your answer?
330.
Yes.
Okay.
Correct.
So in this problem, Leo give everyone a mooncake, so all people eat. So we have x plus y plus z plus w plus v equals 12.
Okay, so can I just do this?
Okay.
All right.
And then we have e equals 12 minus h plus w plus l plus a.
Okay. E equal minus h plus w plus l plus a. Okay.
I can't see your writing for some reason. Oh, sorry. And then, so since no people can get 0, h plus w plus l plus a can be 4 to 11.
So this can be 4 to 11. Okay.
So we just count all the possibilities in which they add up to 4 through 11. In x plus y plus z plus w equals 4. Here, write that.
Okay. Okay.
We have only one solution.
Okay.
And then for 5, you have like this. Here's how I did it. So I made a equals 5 minus h plus w plus l.
5 minus, okay, a, so h plus w plus l plus a is 5. Then a equals 5 minus, okay, h plus w plus l, okay.
And then h plus w plus l can be 3 or 4.
3 or 4, okay.
For 3, there is one solution. For
three?
4,
There's one solution for 4.
there's 3 solution because it just
Three solution.
depends on where you put the 2. It's 1, 2,
Okay.
1. And then, so that makes 4 total.
So that will be 4 here.
Yeah.
Okay.
And then you have 6. So
Equals 6. Okay.
and then so the H plus W plus L can equal 3, 4, and 5.
Okay. So these 3 will be 3, 4, or 5. Okay.
3 has 1, 4 has 3, and 5 has 6. So basically,
1, 3, 6. So in
I
total,
found the
that's 10.
Yeah, I found a pattern that
Okay. What's better?
from 3 it is the sum of the first positive number. 4 is the sum of the first 2 positive numbers. 5 is the sum of the first 3 positive numbers.
Yeah. So this is 1. This is 1 plus 2. This is 1 plus 2 plus 3. Yeah.
And then so you have and for 7 you have sum of the first 4 numbers of the first 4 sum.
Okay. So you have 1 plus
15.
2, 1 plus 2 plus 3, 1 plus 2 plus 3 plus 4, right?
Yeah.
Okay. So that's, there will be 3, 4, 5, 6, right? So add up to what?
20.
20. Okay.
And you keep going. For 8 you have 35.
For 8 you have 35.
For 9 you have 56.
For 9.
56.
So see here, from 20 to 35 is 20, 15. So this is 10 plus 10. And then here you'll be adding 21. So that'll be 56.
And
then
10 is 84.
That'll be plus 28. So that'll be 84. Okay. 11.
And
Did that go to 11?
120.
Yeah, it goes to 11.
120.
At 36, that's 120. So now you add up these numbers, right? 120,
Yeah.
84, this. Oop. Oh. Okay, add up these numbers. Here, right? So let's add them up. So this is 5, 15, 35, 70, 70, 126, 210, and then 330.
330.
Right? Very good. Good. This is organized counting. Very good. Leo, did you figure out your way?
Yeah.
Okay, go ahead.
So something with the arithmetic.
Okay.
So when you subtract 56 minus 21, you get 35.
Oh, here's 35, right?
Yeah.
So 35. Very good. Okay. And
So
then 35 minus
15 is 20.
5 minus 15 is 20. 20 minus 10.
Is 10.
10. 10 minus
6.
6 is 4. 4 minus 3 is 1, right?
Yeah.
Okay, so it's arithmetic, right?
Yeah.
Okay. And then what?
And then you just add them all up.
Add which numbers?
Well, you also need to add on 120.
All right, you need to add 120. 120 is here, right?
Yeah.
These ones. That's when this is equal to 0, right?
Yeah.
So 0, you have 120. And then you add up all these numbers. Did you find some familiar things? You're adding up these numbers the same as where? David. David started with 1, right? 1, 4, all the way to 120. Right, so this David from 2 different angles. They are both good. They are both organized counting. Okay, very good. There are easier way to solve this problem.
Kyle,
Okay, go ahead, Kyle. I bet your way is my way too. So I want, you can start with problem 2 and then talk about problem 1. Is that okay?
okay, so first, mooncakes and people is actually pretty similar to stones and sticks.
Okay. Yeah, explain. You know, people may not know the stone stick thing, so just explain what you mean. Okay.
Stones and sticks is where you have this amount of objects and you need to split them between this amount of people, and then you use sticks to separate the objects into groups.
Okay, so let's use sticks to separate mooncake then. All right. So we have 12 mooncakes. 11. Let me draw one here. 12. Okay, we have 12 mooncakes, and then you're going to use sticks to separate them, right? How many sticks do you need?
There are 4 sticks because for 5 groups you need 5 minus 1 equals 4 sticks.
Okay, so let's say if I put a stick here, stick 1 here, another stick here, another stick here, another stick here, then we separate them to 5 pieces, right? So I mean
Yeah.
five groups. So this will be for the first one, for the second one, for the third one, for the fourth one, for the fifth one, right? So everyone has a few mooncakes. Now we only use here it's because it's 5 people. So we only need 4 sticks, right?
Yes, so next is that since this problem says that no person can have 0, that means that no sticks can be on the edges or no 2 sticks can be on the same spot.
All right, so basically we cannot put, let's say there are a few mooncakes. We cannot put a stick here and then another stick on the same, you know, between the 2 adjacent mooncakes, right? Because if we are doing this way, then we have one person here, another person will be between these 2 sticks, that person will have 0 mooncakes, 0. And that person will cry, okay? Cry, will cry.
What about
Okay, so that's probably Leo, right? So Leo will cry if he didn't get any mooncake, right? So we cannot put 2 or more sticks in the same spot. Okay, when I say spot, that means between 2 mooncakes, between 2 adjacent mooncakes. Okay, keep going.
Okay, so now you can conclude there are 11 spots.
All right, there are 11 spots because we have totally 12 mooncakes. And then there are only 11 spots between these mooncakes. Okay, 11 of them. 10, 11. Okay, why not here? Why can't we put a stick here?
Because if you put a stick then the edge people will get no.
Yeah, let's say Leo is here, right? Leo will get 0 stick again, 0 mooncake again. So we don't put a stick here, right? So let's be nice to our family members. Okay, and then what? So 11 spots.
So since it is 11 spots and 4 sticks, then it will be C11-4.
All right, C11-4, right? So that's 11 choose 4, right? 11 times
10 times 9 over.
right?
And then you can cancel all of them out.
Cancel these, cancel this. So that's 330, right?
Yeah. So this actually leads to the general formula. So
Okay.
suppose if there are M mooncakes and S sticks.
Okay, N mooncakes. Okay, and S sticks.
So and then suppose if it says that you can't give 0 mooncakes to any person. So with the same thing in mind, so first there's a solution number 1, so you do Leo's way, but I'm not going to continue that because for solution 2, well, so for solution number 1, there will be n minus s minus 1.
Where is X? Oh, S. Okay, N minus S minus 1. This is what?
This is the amount of mooncakes if you're doing it Leo's way.
Oh, no, let's do your way. So
No,
Leo,
no, no. No. I need to reference it. I need to reference it so that you know that there are n minus s minus one.
Okay.
Wait, n minus s minus one mooncakes and s sticks.
Okay.
And then for solution number 2, you just do it my way. So you first put n mooncakes. You don't really need to draw that. So there will be n minus 1 equals 11 spots.
Okay, n minus 1 spots. Okay, n minus 1 spots. Okay, so these are basically adjacent, you know, the spots that we can put the sticks, right? So if there are n mooncakes, then there will be n minus 1 spots, okay?
And then it will just be c, and then you can conclude that would be c n minus 1, c n minus 1 s.
Yes, right? So from n minus 1 spots, we're putting s sticks, right? So that's a general formula for this case. If we are giving at least 1 mooncake to each
But
family.
that can prove in even more general to, like, you can just have you can just it's just regular for problem number 1.
Okay, so let's talk about problem number 1. So what if someone can, you know, they may
wait,
have
actually, I
0
need
mooncake.
on the general formula.
Huh?
To do problem number 1, I just actually used the general formula.
Okay.
I proved.
Go ahead.
So that means if there are actually if the number of mooncakes is actually n minus s minus 1, so n minus s minus 1 equals let's say that it's actually there's actually first n1 minus 1 and n1 mooncakes and s sticks.
What do you mean n1 mooncakes? Just n mooncakes, right?
No, n1 because I have to because I'm going to discuss a different case.
Oh, okay. How about m?
Okay.
M mooncakes, okay.
So m equals n minus s minus 1, and then s is still the same.
Why? I mean, we are talking about m mooncakes. We are splitting m mooncakes to well, you say s people. Let's say m mooncakes to p people.
No, actually, it's related, so you don't have to draw that line.
Yeah, that's fine. Go keep going. I'm just trying to make the notation straight. We have m mooncakes and p people. Now you go
No,
ahead.
actually, the s is the same.
Huh?
The s is the same.
Well, the first one is s sticks, and here
I
I'm
know.
saying we have p people.
No, I'm not talking about that. I'm saying that it's a different case, but it has some of the same variables.
I don't need a same variable. I want you to articulate a problem using m mooncakes and p people. Either use m mooncakes, p people, or 12 mooncakes and 5 people. Try it.
Can you just make it s sticks? It's the same number.
Yes, it's the same number, but I want you to try a different variable, right? So I don't want you to recite a formula, okay? I want you to show your understanding and convey that to the other case. Try it. Or you use 12 and 5 rather than using your formula. All right, so for this type of problem, okay, if you remember, if you know the formula, that's great. But you know, I don't like to make this a memory test, right? So I want you to make sure you understand it. You know, make sure you know the basics of counting method, like what Leo and David did. And then, you know, when we explore the more advanced method, like combinatorics, like these formulas, then I really want to make sure you guys understand what's behind it. Okay, so if the formula says S, and then when I change it to P, you don't know how to do it, that's not enough, all right? You want to try it? Either NP or 12 and 5. You there? Kyle? No, I guess Kyle is off. Anyone else want to try this? Oh, am I off? Can you guys hear me? Yeah, okay. Anyone want to try this? Okay, Shiyin, go ahead.
I said I didn't really want to try it, but I just said that we can hear you.
Oh, okay. Okay. Anyone want to try this?
Which one?
You're using Kyle's method?
Whoever's method is.
Stars and bars method. So basically, if we're number 2,
Okay.
like now that you have to give one to everybody, just like give one to everybody at advance, and then use the stars, and then use like the dividers and like the mooncakes method.
Okay.
So that way you still have 4 dividers because you have 5 people, but now you only have 7 mooncakes left because
Okay,
everybody.
hold on. So now I have 7. Which problem you're talking about? The second problem or the first
Yes,
one?
second.
The second one we have 12 mooncakes.
No, because you have to give one to everybody. You have to give one, and then since there's 5 people.
Oh yeah, the second. Okay, yeah. So
You subtract 5 from 12, and then you have to still put 4 dividers in, and then you like do the same algorithm.
That's the second problem, right?
Yes, it is indeed.
Yeah. So we have finished the second problem. Now we are going to the first problem. Problem number 1. Then someone may have 0 mooncakes.
Yeah, that's entirely possible.
Yeah, it is possible. So how many different ways to allocate the mooncakes?
You can just put 4 dividers into 12 mooncakes,
Okay.
and so 12 plus 4 is 16.
Hold on. Why do you do 12 plus 4? What is that 12 plus 4 thing? Now I have.
Because I want to use combinations to see how many ways there are to arrange the dividers and the mooncakes.
So how many dividers you're using? You have 4 dividers?
Yes.
4 dividers?
Yes, and then since there's 12 mooncakes, the number of ways to do it is the number of ways to arrange the dividers in the mooncakes.
Why is that? Why now you have 12 plus 4? In the first time, we only have 11, right? We had 12 minus 1, and now we have 12 plus 4. Why do you have 12 plus 4?
We have 12 plus 4 because you have 12 mooncakes, and then you have to put in 4 dividers to see how much everybody gets.
But in the first time, I need to put in 4 dividers too. Then why is 11 choose 4? What's the difference? See, the first one, I also had 12 mooncakes, right? And
Yeah.
then I have 4 dividers, and then Kyle said we need to do 12 minus 1 because there are 11 spots. So we choose 11 choose 4, right? So here, why do you do 12 plus 4?
I do 16 choose 4 because
Okay, so you do 16 choose 4. Why do you do 16 choose 4?
Because there's 12 mooncakes, 4 dividers. You want to try to find the way to arrange the mooncakes. The total number of things, choose dividers.
Yeah, but the first time it was also 12 mooncakes, 4 dividers, right?
Yes.
I have a question.
Why didn't you do 16 choose 4 in the first place? Let me, was that Eric?
No, I just have a question on what the answer to the problem 1 is.
I think it's 1820.
Oh.
I think the problem 1's answer was 1820. Okay. Was that first of all, was that Eric who was speaking with me for the 16 choose 4?
Wait, I think I got something wrong.
Okay. Well, what did you get wrong? I need people who explain why it's 16. Okay. The first time was 11, then this time was 16. Why? I need someone to explain this to me. Okay, I know some of you learned the formula, but that's not the goal of math is not just to learn the formula and know how to apply it. Okay, so I want you to really understand where the formula is from. Okay.
I'm trying to learn the formula. I'm trying to prove the formula.
Okay, go ahead, prove it.
So, can you just draw? So, just can you draw a line, Andrew?
Draw what?
Draw a line so that I can start a new section.
Okay, so you want to start a new piece? Okay.
So as I said before, see that there are M mooncakes and still the same S sticks.
M mooncakes. S sticks. Okay.
Mm-hmm. So M equals. Can you go up again? Wait, like before column number 1.
Here.
Wait a second. A little down. Can you move a little slower? I can't really catch up. Yeah, so M equals N minus S minus 1.
What is N? You didn't
N,
define.
I already defined it in previously. I tried to prove it. So S and N are previous variables.
Okay. So previously we have N mooncakes as sticks. And where is this M then? You just define M as M mooncakes.
M is.
Oh, actually, I feel like I got it. So basically, you have to,
Hold on. No, not your turn yet. Okay, so this is
Okay.
Kyle's turn. We need to let Kyle try. Okay, until I ask anyone else.
So M is N minus S minus 1.
M is N minus S minus 1. Why did you define it this way?
So since before I talked about solution 1, there would be N minus S minus 1 mooncakes and S sticks. So I'm just redefining it to be N.
No. The first one had N mooncakes. There's nowhere.
No, I said
S minus 1.
I said there was solution number 1 and solution number 2.
Okay.
And this is for solution number 2. We've already
I'm confused. Sorry. Keep thinking. All right. Anyone else?
I'm David.
Can I go again, please?
Yeah, you're Eric, right?
Yes. So
Okay,
instead of like doing 12 plus 4, we have to try to like fit between the gaps because like you don't like overlap the sticks with the stones.
Okay.
So you have to go between the gaps. There's 11 gaps. You can count them.
All right. So there are 11 gaps. All right.
So 11 choose 4 because you have to put 4 dividers in.
11 choose 4. Then this is the same. This was a solution. This was a solution to problem 2, right?
No, this is problem 1, isn't it?
Nope. This is problem 2. We started with problem 2. Everyone has at least one piece. Okay. And we have finished problem 2. Now we are going back to problem 1.
Yes, this is for problem 1.
It is not. Okay, it is not. This is the answer to problem 2. Okay.
I have
Leo,
another solution, David.
hold on, David. I'll let Leo try first.
I think after you first need to do 11 choose 4, but then you need to add stuff. So first, I think we need to add if one person gets 0 and then.
Okay. Oh, okay. Good idea. So I start with 11 choose 4. 11 choose 4 is everyone gets 1 or more, right?
Yeah.
Okay, then that's how many ways we can have it. And then you said you need to add what?
Add the number of ways that someone could get 0.
Okay, so let's start with Leo gets 0. Okay, let's say Leo gets 0. Leo gets 0. Okay, in the first case, 11 choose 4, everyone gets 1 or more. And then, we have 11 choose 4, right?
Well,
So,
and then you need to add 11 choose 3.
okay, then the next one, if Leo gets 0, there'll be 11 choose 3. And then what else?
And then you need to multiply by 5.
You need to multiply by 5. Why do you multiply by 5?
Because there are a total of 5 people
Oh,
that
so
get it.
Leo may get 0, and say Dr. Hong may get 0, and Dr. Wang may get 0, and Angela may get 0, and Yira may get 0. So we need to do 11 choose 3 times 5.
Yeah.
And then let's see if we add them up, what we got. All right. So 11 choose 4 is what? 330, right? We just calculated. 11 choose 3. 11 times 10 times 9 over 3 times 2 times 1, right?
Yeah.
So that's
3, 165.
5. So 165, right?
Yeah.
And then 165 times 5 is what?
490. Wait, 165 times 5 is 825.
825. So is the answer 330 plus 825?
No.
What else? What else are you
You also
missing?
need to add if 2 people get 0.
Oh, 2 people get 0. Okay, let's keep trying. So let's say if Leo and Angela get 0. Okay. And then what do we got here?
Then you have 11 choose 2.
Oh, 11 choose 2, right? So now we only need to choose for the other, we only need to allocate the mooncakes to the other 3 people, right?
And then you multiply it by 5 choose 2.
By 5 choose 2. 5 choose 2 is 10, right?
Yeah.
Okay. So what is this? This is equal to 11 times 10 over 2 times 1 times
Which is
10.
550.
550. Wow. Is that done? So here plus 550?
No.
Okay, what else?
You also need to add 3 people.
3 people. Okay, so let's say 3 people. 3 people.
You.
Okay, me. Okay. Let's say 3 people, right? Get 0.
You never add yourself.
Okay. And then what do you get?
So then you get 11 choose 1,
Okay.
which is just 11.
Okay.
And then you multiply it by 5 choose 2, because 5 choose 3 is the same as 5 choose 2.
It's 5 choose 3, the same, so that'll be 10.
That's 110.
110, okay.
And then you need to add 4 people.
4 people get 0, right? 4 people get 0.
So then it's 11 choose 0, which is just 1.
Okay.
Times 5 choose 4, or 5 choose 1, which is just 5.
Okay.
Which is equal to, yeah.
All right, so plus 550 plus 110 plus 5.
That's all.
Add up all these numbers, okay? You're getting, I think, 1820.
Yeah.
Okay. Okay, so Leo just used the previous 11 choose 4, 4 sticks across this 11 gaps, okay? 4 dividers on the 11 gaps. Then we can do it this way. But I still like with Eric early on mentioned actually 16 choose 4. That's actually the easiest answer. Why is 16 choose 4? I still need people to explain this to me. Okay. Actually, by the way, if you do 16 choose 4, then you're getting the same number. Okay. 16 times 15 times 14 times 13 over 4 choose 3 times 2 times 1, and this is also 1820. Okay. So I need someone to explain to me why is 16 choose 4.
Kyle.
Okay, go ahead, Kyle.
So can I continue on my
Okay, sure.
Okay, so you remember from last time is that there's the first solution. We continue on with the first solution.
Okay.
For first solution, so there are m mooncakes.
Okay, M mooncakes.
No, I mean m.
Okay, M mooncakes. Okay.
And then n equals n plus n minus s minus 1.
Well, we're going back there. So why is M is N? What is N? What is S?
S is the number of sticks, and
Okay.
you can remember from the start of my proof that S is the number of sticks for solution number 2, and N is the number of mooncakes for solution number 2.
Okay, let me give you a hint. Okay, what this is doing is actually, if we started with 12 mooncakes, okay, if we start with 5 people, okay, what you're doing here is actually is 12 minus 5. Okay,
Yes.
you have S minus 1 is the same as minus S plus 1. Okay, I was saying there were P people. This is actually P. Okay, you had the number of mooncakes minus the number of people. Okay, because each people will have at least 1, and then the remainder you define it as M. So that means for the remaining M mooncakes, when you allocate these M to P people, okay, then these people may get 0. Some of them may get 0, right? So that's where you get is N minus S minus 1. Okay, I'd like you to understand why it is this rather than just get a formula. Okay, keep going.
Yeah, so then you get that N equals P plus M.
N equals P plus M.
And then you remember the previous thing is that for when there are n mooncakes and s sticks, and each person has to have at least 1 mooncake.
Okay. Yeah.
It was a solution of C. Can you go back?
It's C11(4). Okay. So N will be, that will be Cn minus 1, P minus 1. P is number of people.
Mm-hmm.
Okay.
And then N is P plus M.
N is P plus M. Okay.
So you get the final solution C P plus M minus N minus 1 M minus 1 P minus 1.
Cp plus M minus
Yeah.
1.
Mm-hmm.
P minus 1, like this.
Mm-hmm.
Okay.
For M sticks and P for M mooncakes and P people.
Okay. M mooncakes. Cakes. P people. All right, very good. So you're getting this. So what Kyle is doing, Kyle started with the problem that we said, okay, everyone will have at least 1 mooncake. But that's basically equivalent. That's equivalent. You know, let's say 12 mooncakes, 5 people, okay? If everyone has at least 1 mooncake, that's equivalent to allocate 7 mooncakes, 12 minus 1, 12 minus 5, 7 mooncakes to 5 people, with some people may get 0, right? So these 2 problems are equivalent. That's where Kyle derived to this this one, okay? C, P plus 1, minus 1, and P minus 1, okay? And then what?
And then you can apply the final solution to problem number 1.
All right, so now we apply this. So this is the algebraic way of doing things, right? So Kyle basically derived the formulas out. So now let's say, 12 allocating 12 to, N is 12, P is 5. Allocating 12 to 5 is equivalent to allocating, with 1 or more, 1 plus mooncake per person, okay? Okay, that's equivalent to allocating 7 to 5 with 0 or more per person, right? And then Kyle derived this formula. So now let's see, okay, what if we have 12 mooncake to 5 people, but some of them may get 0? Then that'll be going back to this formula. That'll be C, P is 5, M is 12, minus 1, over P is 5, minus 1 is the same as C, 16, 4. Okay, very good. So this is an algebraic way of deriving this formula. Okay, good. Anyone else? I still need an intuitive way of understanding this. Why is C16?
I'm really confused on this. So what was N again?
N was the original mooncake. So remember when we discussed problem number 2, where I said we have 12 mooncakes and each person will have at least 1, right? Let's look at this. When Leo did the first one, so we have 12 mooncakes, right? And then each person will have at least 1. So what Leo did at the beginning was to give each person 1 mooncake, right? Basically gave them 1 to satisfy that condition. And then we have 7 mooncakes left. And to allocate these 7 so that some people may get 0. And then, we did a calculation like this, right? So that's where this, where this 12 minus 5 is, okay? N will be the 12, N will be the 12, 5 will be the 5 people. So N is the number of mooncake when you allocate to people. Each one will have at least 1. And then when we minus the number of people, we have M. M is the number of mooncake. When we allocate out, some people may not get any of the M. All right? So again, back to my question. I need someone to explain
So
to
N
me.
is 17.
Huh?
So N is 17.
N is 12.
Wait a
N
second.
is,
Oh,
N is 12 in the original problem. Okay?
How's N is how is N 12?
At the beginning, we have 12 pieces, right?
Dr. Hall?
Yeah. In the beginning we have 12 pieces, but
Yeah. So
Dr.
that's
then-
problem number 2. That's problem number 2. We have 12
Dr.
pieces.
Hall?
No,
how did you
finish.
get 7?
Dr.
12
Hall?
minus 5 is 7. Kyle, let me finish. 12 minus 5 is 7.
Oh, okay.
All right. So basically, these 7 is to allocate 7 so that people may or may not get any of them. Okay. And then if you go back to problem number 1, I said it's 12 pieces to 5 people. I didn't add any constraint. I didn't say everyone will have at least 1. You look at this problem. Look at problem number 1. There's no constraint. I just say how many different ways can Leo allocate this mooncake, right? So that means allocating that 12 is similar. It's a similar analogy of allocating these 7 when you and Leo allocated, right? You and Leo allocated these 7 mooncakes to people so that they may get 0, right? So now we're just changing, instead of allocating 7 here, we're allocating 12 here. That's what Kyle did with the algebraic way of derive that equation, okay? C, number of people plus number of mooncake minus 1, choose for number of people minus 1, this the number of dividers, okay?
Dr. Hall, I have
Yeah,
to
I
go.
see. Yeah, I know.
All right, Kyle. Okay, Kyle, go ahead.
No, I mean I have to go. I have to leave the meeting now.
Yeah, I know you have a soccer practice, right?
Yeah. Bye.
Yeah, have fun there. Bye.
Wait, how does he
Any
have
other
a
comments on it?
how does he have a soccer
Huh?
practice? It's like 8:45.
He lives in Seattle,
Oh,
William.
He's in Seattle. William, the smart kids are not just in Charlotte. Okay, so Charlotte has some smart kids. Seattle has smart kids too. Okay, all right. And actually, Eric is from Seattle as well, and the Xuyun is from Seattle as well. Actually, there are 3 people. 3 of you are from Seattle. Okay. Anyway, I still need you guys to explain why is 16 choose 4. Huh? Okay,
Isn't
go
it
ahead.
because there's 11 spots and then there's 1 on the edge and then there can be 4 in the same spot, so it's just 12 plus 4.
Oh, who's that?
Kenny.
Kenny. Okay, so there are 11. Okay, let me draw.
There's
mooncakes.
There's
So there are
11
11
in
gaps.
between, 11 gaps, and then there's the edge on the edge. There's one more.
Okay.
So that's
Well, there are
12.
two edges. Well, hold on. There are two edges.
Well,
What do
yeah,
you mean by one more?
yeah, well, yeah. And then, so then there's, you can group up to 4 in the same edge.
You
Well,
can
not,
put 4 on the same edge. Okay, 1, 2, 3, 4. Okay.
and then, so then it's 16.
That's 16. So how many? So I have
Wait,
11 plus 2 edges plus
wait.
4. That's how many?
Wait, no, you can't put,
That's
wait, hang on.
where'd
Something's
you get
wrong.
16?
Something's wrong.
Yeah, something's wrong. Yeah, I know. Okay, Leo.
So I think you can just kind of like just put the 4 sticks
Okay, 4 sticks,
and the 12 mooncakes all together.
12 mooncakes.
Yeah.
Okay,
And
12,
then
4. Yeah, this is 16. But why do it this way?
and then I think you can. And then you can, I think, wait. And then you can put a stick on either of the 4.
Mm-hmm.
And you can also put a stick in between each of the mooncakes or at the very end.
Okay, so I can put these sticks. I can put all 4 sticks here, for example. 1, 2, 3, 4.
Yeah.
Okay, so what?
So then, wait. Oh, never mind.
Okay, anyone else want to try it?
No, I know why I got something wrong. It's because the 2 edges are actually the same. It's just that you arrange them on a line, because if you arrange them in a circle, then there's only 1 edge and there's all gaps, and the edges are the same. So if you put 2 on one side and 2 on the other side, just it's the same as putting 4 in one edge.
Oh, okay, I like your idea. You said arrange them in a circle, right? Arrange them in a circle. Arrange all the mooncakes in a circle. Then there will be 12 gaps, okay? And then what?
And then you can put up to 4 in the same spot, so that's 12 plus 4 is 16.
Okay, I can put 4 in the same 4 sticks. 1, 2, 3, 4 on the same spot. That's fine. And then what? Why is it 16? See, if I put these 4 on the same spot and I have 11 other places I can put them, why not 15 choose 4? Why is it 16 choose 4? Yeah, why is that? I know this is a formula. This is a famous formula. You will find this formula
Yeah, I think I know
from
why.
many sources. But I
I
want
think
you
I
to
know
understand
why.
it. Okay? Was that David?
Can you draw 11 circles?
11 circles.
No, I mean
One-
12. Sorry.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay?
And put 2 bars on either side.
A bar here and a bar here. Okay?
No, and another bar. Add another bar.
Like this.
Yeah. So
Okay.
there you go. You have 16 of them. So 16 choose 4 equals 300. 18, 20.
So why is this? Yes, we have 1, 2, and 12, and 1, 2. Then what is the difference between 1, 2, 3, 4, and then these 12 circles? Why this one convinced me is 16 choose 4?
Well, because the bottom one is the same thing, right? It's also 16 choose 4. So you only have to put.
It's also 16 choose 4. Why? I mean, the question is why. So I'm putting 4 sticks here and 12 mooncakes there. Then what does 16 choose 4 mean?
So basically, there's 16 possible choices, and you're making 4 choices.
16 possible choices of what?
Of grouping.
Of grouping what?
Grouping the sticks. I mean, grouping the cookies.
Grouping the cookies, okay? The mooncakes, okay? All right, so guys, for the interest of time, we already go beyond 1 hour, right? So let me explain to you what's going on, okay? Hopefully you can get it, okay? Look at this. We have 16 objects, okay? 16 objects. If we shuffle them, if we just shuffle them, okay? We can put 2 bars here and a few mooncakes here, and then a bar here and a few mooncakes, and then a bar here. No matter what we do, there will be 16 slots, right? There will be 16 slots. What we are doing is actually putting 4 bars on these 16 empty slots. We're putting bar here, and bar here, maybe a bar here. And then the remaining ones will be mooncakes. That will give us an allocation, right? So we're actually grouping the bars. Well, not grouping the bar. We're allocating the bars, these dividers, on these 16 different spots, okay? On 16 different spots. And for every, whenever you shuffle them, you come up with a grouping of mooncakes to allocate to people. So in this case, 1 mooncake, 2 mooncake. So this will be 9 mooncakes. And then this one will get 0. And this one will get 0. This person will get 0. Okay, 0 and 0. So we're putting 4 dividers on a 16 slot, on a field with 16 slots. Okay, you can consider them as 16 plates, and then you're putting mooncakes and bars. Huh?
I mean, wasn't that sort of what I was saying? Like basically 2 of them are the same.
Say again?
Wasn't that sort of what I was saying? Because I said 2 of them are the same. Like the 4 bars on one side, 2 bars on the other side.
Yes, but I didn't get that 16 slots. Okay, we have 16 slots, and we're like allocating 4 bars. You can put this way, and then there will be 12 mooncakes here. So then there will be someone gets 0, another one gets 0, and then one get 12, and one gets 0, and one gets 0. This is just one way to allocate these bars. The difference between this problem and the problem that everyone will have at least 1 is that here you can put 2 bars adjacent to each other, okay? Because basically you can randomly assign the 4 bars among these 16 slots. But in the other problem, you cannot. Because when you assign 2 bars next to each other, someone will get 0 mooncakes.
So you're basically just kind of putting 16 objects, you know that they're objects, and you're choosing 4 to be bars?
Yes, 16 objects and choose 4 to be bar. 16 empty spots. I put 4 bars on these 16 empty spots. The rest will be mooncakes. Okay? All right, guys. I think if you know this, if you know these 2, the next 2 will be easier. We don't have time to go over the other 2. Yeah, maybe next week we can talk about the other 2 next week. Okay? I will set up time for next week. Same people. We will be meeting next week to discuss the other 2 problems. Okay? Yes, I want you to understand that the purpose of this is not for you to memorize the formula. It's for you to understand the process, why we're getting this formula. Okay? I like Kyle's way very much. He used algebra to derive the formula, but still I need an intuitive explanation from you guys so that I know you understand the formula. Okay? All right, guys. I will see you next week. I will see the same group next week. Okay? Bye.
Bye. Thank you.
Bye. Thank you.
Thank you. Bye.
I have a question.
Oh, okay. Who's that?
Bye.
Seeing.
Okay.
So I don't really understand because I'm still in 3rd grade, so I don't really understand what this is all about.
Oh, that's fine. You're you know, there's still a long way to go. This is middle school, high school stuff, so that's fine. You did it right? You did a problem right?
Yeah.
So how did you do it? Did you count it?
Yeah, I just counted it.
That's great. That's you know, at your age, that's what you're supposed to do. You know, no organized counting like what Leo and David did at the beginning. You saw those, right?
Well, yeah, I just counted it. Well, first, since I couldn't even understand the part of it about counting, like counting it and like dividing it with the 5 people, so I just started at 1 mooncake, 1 person sharing.
Okay.
There's 1, and then 2 pieces of mooncakes and 1 person all the way until 12, and then after I did 2, 3, 4, and then all the way to 5.
Mm-hmm. Excellent. So basically, that's you're looking for the pattern. That's great, right? So the elementary school, that's what you're supposed to do. That's great. All right. So that's organized counting. That is organized counting. Okay. Good. That's okay. If you don't understand the combinatorics part, that's what you learn in probability later on. Like, you know, maybe in the 7th, 8th grade, you learn probability. You will learn some of these. Then don't worry about it. For now, I'd like you guys to master counting. Okay.
Okay.
All right. You did a good job. I think you're one of the perfect scorers, right?
Yeah,
Did
I
your
was
dad tell you? Yeah. Congratulations. It was good job, right? Okay. Have fun, guys. We'll see you next week. Okay.
Bye.
Bye.